Okay, hello everybody. Okay, for this particular exercise, as usual, I'll give 5 questions. Okay, this time I'm giving question 11, 12, 14, 19, and 20. Okay, so before I begin, just a quick recap. Okay, in the topic of spheres, the two main formula that we have learned, okay, is that the surface area of a sphere is 4 pi r square, where r is the radius, and the volume of the sphere is 4/3 pi r cubed. Okay, so these are the two main formulas that you have learned. Of course, there are formulas for hemisphere. You just basically need to halve the surface area and half the volume, and you can get them respectively. So you don't need to go and memorize another set of formulas. Just understand the first one will do. Okay, so let's begin. Okay, the first question 11. Okay, we have a capsule consists of a cylinder. Okay, so this is the cylinder in the center and two hemispherical ends. Okay, so this is a hemisphere, this is a hemisphere, which shares a common base of diameter 7 millimeters. Okay, the capsule has a length of 20 mm. Find the volume and the surface area. Okay, so how do we break this down over here? Okay, so you might realize that, okay, this hemisphere and this hemisphere can combine to give you one complete sphere. Okay, so to find the volume for such figure, so usually when it's a composite figure, you either break it down into smaller parts if it is made out of a few parts add up together, or it could also be a part removed from another part. So in this case, I have things being pieced up together, so I need to find the volume of the sphere and the volume of the cone. So how do we find this? For cones and for spheres and cylinders, okay, one of the very important dimensions that we need to have is the radius. Key thing to take note over here, you are given the diameter of 7 mm, so you need to convert it into radius, which will give you 3.5 cm. Just let me do a quick drawing here. Okay, so this means that, okay, over here the radius is 3.5 mm. Okay, and some of you wonder, then how do I know what is this length over here, okay, of your cylinder? Okay, key thing to take note, for a sphere, the radius, okay, is the same in any direction. Okay, it measures from the center. So if from the center to this side is 3.5, from this center to the other side will also be 3.5. This means that this side is also 3.5. So if this is 3.5, this is 3.5, these two ends will add up to 7. And with the two ends adding up to 7, this tells you that the length of this cylinder, okay, is about 13 mm. Okay, because you take 20 minus away 7. So with that, let's begin our calculations. Okay, so to find the volume of the capsule, like I said, okay, you will need to calculate the volume of the two hemisphere and the volume of the cylinder. So volume of the two hemisphere, okay, one sphere, okay, just now we just said volume is 4/3 pi r cubed. Okay, so 4/3 pi r cubed. Okay, volume of cylinder, okay, is the base area times the height. Base area is pi r square, times the height of 13. Okay, so you can see over here, 4/3 pi r cubed. R cubed is 7/2, so it's 3.5 cubed plus pi r square h. So my r is also 7/2, but square times h of 13. So this is how I get my 13. Just now I've explained to you. You add them together. Okay, correct them to 3SF, about 680 millimeter cube. So take note, okay, because this is pi, you will not be able to get an exact whole number, so you always correct to 3SF. Okay, unless the question asks you to leave your answer in pi. Otherwise, if they never say anything, you just calculate it out. Take note of your units. In this case, it's in millimeters, so it's millimeters cube. okay, because volume. Okay, next I have surface area. So surface area in this case, there are three surface areas. Okay, this hemisphere, which these two adds up to give you a sphere. Okay, and this curved surface of the cylinder. So you do not need to take account the circular surface, okay, over here, because this is enclosed. So it's just the curved surface and the two hemisphere. Okay, so for the two hemisphere, basically they just make up the one sphere. The formula with 4 pi r square. Over here, for those who have forgotten, okay, to find the curved surface area is just the circumference times the height. Okay, the circumference of this, because when you open up this curved surface, it gives you a rectangle. Okay, rectangle with the height, okay, over here, and then the circumference will give you the length. So the circumference will be pi d, or 2 pi r, okay, times 13. Okay, so 2 times curved area of hemisphere plus curved area of cylinder. So 4 pi r square. So this time around, they instead of put as 7 over 2, they put as 3.5. So 4 pi times 3.5 square. This is 2 pi r times 13. So 2 pi r is the circumference. Okay, so 2 pi times 3.5 times the just now we calculated that the length of this cylinder is 13. Okay, so as usual, key everything in. Okay, about 140 pi, you evaluate out. Okay, 440 millimeter square, correct to 3SF. Okay, so with that, that's our first question. Okay, it's pretty straightforward. Okay, even though it is can be a bit tedious because it's a composite figure making out of a sphere and a cylinder. Okay, next question, we have question 12. Question 12, okay, a watermelon can be modeled by a sphere with a radius of 10 cm. It is cut equally into 16 pieces. Find the volume and the curved surface area of one piece. So basically, with 16 pieces, you just take the total volume divided by 16. So the total volume will be 4/3 pi r cubed. So 4/3 pi, my r is 10. So 10 cubed. Okay, I get about 4,000 over 3 pi cm cubed. Then you divide it by 16. So you times 1 over 16, you get 250 over 3 pi. Evaluate it, you round off to 3SF, you get about 262 cm cubed. Okay, correct to 3SF. Okay, curved surface area. Okay, so you'll be just 4 pi r square and you divide it by 16. So yes, over here you can see that it's divided by 16, 4 pi r square, where r is 10. Okay, evaluate this, it's about 25 pi, which gives you 78.5 cm square. Okay, correct to 3SF. Okay, so question 12 is pretty easy, pretty straightforward. Okay, so let's move to question 14. Because question 12 is just a sphere, okay, I didn't go into any composite figures or anything. Okay, so question 14. Over here, the diagram shows a cylindrical container. Okay, so this is a cylindrical container. The base radius is 12. Currently, it's filled with water up to 10 cm depth. Okay, find in terms of pi the volume of water in a container. So it's just basically finding the volume of a cylinder. So in this case, with a radius of 12, with a height of 10. So just now I just said, okay, volume of cylinder is base area times height. Okay, so base area pi r square, so pi 12 square times height of 10. Okay, so pi 12 square times 10, 1440 pi cm cubed. So over here, because the question say find in terms of pi, okay, so the answer is left without evaluating the pi. Okay, so this one is every time you do such questions, okay, like spheres, cylinders, cones, where there is some pi involved, look out for the question. Okay, the question may ask you in terms of pi and all this. Okay, when a solid metal sphere of radius 4 cm is completely immersed, okay, in the water, what is the rise in the water level? So meaning I add this metal sphere in, the water is going to go up, okay, because your solid metal sphere takes up space. Okay, so there's a volume. Okay, so why is this increase in the height? This increase in the height will depend on the volume of the sphere. Okay, so how do we calculate this? This increase in height, okay, will be a result of this change in volume due to the sphere. So first you need to calculate the volume of the sphere. After you calculate the volume of the sphere, okay, to account it to be added to over here, you will take this volume divided by the surface area, okay, and you get the height increase. So volume of sphere 4 third pi r cube. Oh, okay, so in this case, for the workbook, they decided to combine the two steps together. So just now I was saying 4 third pi r cube, where because this is a sphere with a radius of 4, so my r is 4. So 4 third pi 4 cube. So this volume will be equals to the increase in the volume, okay, over here. Okay, so this increase in volume, because it's a cylinder, we make use of the formula for volume of cylinder is pi r square h. So pi r square h, where r is 12. So h is the rise that you're going to find. So with that, okay, you can straight away solve this equation. The 2 pi on this side will cancel each other. Then you can bring the 12 square to the bottom. Okay, so in this case, they cancel 2 pi. 4 cubed times 4 is 256 over 3. 12 square is 144. So 144h is this. 144 you can throw to this side. Okay, you realize that 256 over 3 times 144 simplify to 16 over 27. Okay, so since this is an exact number, you do not go and round it off to 3SF. Okay, you keep it as exact. Okay, 16 over 27. Okay, so it will be in cm, this volume will be in cm cube. Okay, even though the question asks you to leave terms, things in terms of pi, still need to have the units, okay? Just that you don't need to calculate out the pi, which is 3.14 something, okay? Okay, so that's question 14. We move to question 19. Okay, question 19, we see another composite figure. Okay, over here I have a hemisphere, okay, together with a cylinder. So they tell you that the hemisphere has a head with radius 5. So like just now I said, 5 will go in all directions, be it this direction or from the center to this side. Okay, so the diameter is 10 mm. The cylindrical pin, okay, has a length of 25, diameter of 4, means it has a radius of 2. Find the volume, find the surface area. So usually volume is the easier one, okay, you just need to add them together. But surface area will be the slightly harder one because you need to account, okay, for quite a few surfaces. Okay, so let's start with volume. So I have a hemisphere and a cylinder. So the volume will just be the volume of hemisphere plus the volume of cylinder. So just now I said, okay, hemisphere volume, you don't need to go and memorize. As long as you know volume of sphere, okay, it's 4 third pi r cube. So volume of hemisphere will just be half of that. There will be just 2 third pi r cube. Okay, so half of 4 third pi r cube. In this case, my r is 5, so 5 cube. Cylinder, okay, by now you should know pi r square times h. So pi r square, which is 2 square, times h of 25. So evaluate this, okay, get 576 millimeter cube, correct, to 3SF. Okay, next we have our surface area. So for the surface area of this curved surface of the hemisphere, we have the curved surface of the cylinder. Then you got these two green color surfaces, okay, which actually piece up together to form a circle. You can see that this area will fit nicely in the center here, and they will form a circle with a radius of 5, okay, which is part of the hemisphere. So when you calculate is the curved surface here, this circle, and the curved surface of the cylinder. So surface area of hemisphere, okay, over here, they use half of 4 pi r square. Like I said, you don't need to go and memorize just for surface area of hemisphere. So hemisphere will be 4 pi r square, just apply the half, okay, where r is 5 square. So this pi 5 square, this pi 5 square is this green color area that I was just saying, this side and this side, they add up together, give you one circle with a radius of 5. So area of circle is pi r square. So over here will be just pi 5 square. Then cylinder, okay, just now I already said it will be 2 pi r times h, where 2 pi r actually is the circumference, okay, over here. So you have 2 pi r, the circumference, times h, which is this height. Okay, basically you get a rectangle. So my r is actually 2, okay, because 4 over 2, diameter of 4 divided by 2, my radius is 2. So 2 pi times 2 times 25. So all I need to do is just to solve. So 175 pi, okay, which is equivalent to 550 millimeter squared, correct, to 3SF. Okay, so in this case, they didn't ask you to leave it in terms of pi. Okay, then you just evaluate it out. Okay, so by now you should have been able to notice that questions on mensuration is not very difficult. Okay, it's really just you need to be clear in what are the things to calculate, account for everything. Make sure you substitute in the correct values. What is the radius? What is the height? Know the difference, the differences in the different values. Okay, and can do the calculation. Okay. So we move to the last question, question 20. Okay, so question 20, a manufacturer wants to design a rectangular box to pack 8 table tennis balls, each of diameter 4 cm as shown. So over here is 4 cm. Okay, what should the dimensions of the box be so that its internal surface area is the minimum? Okay, so to have minimum internal surface area, the balls should touch each other and the box. So in this case, basically they already draw out for you quite nicely lah. So basically the best way to pack this is such that it is at the bottom, okay, you put 4 of them, put 4 more on top. This is already the minimum, because you open anything out, actually it will increase the surface area. So if the diameter is 4, if they stack on top of one another, it will be perfectly. Here will be 8, across here will be 8, here will also be 8. So basically your dimension of the box will just be 8 cm by 8 cm by 8 cm. So always remember, when it comes to these last few chapters, okay, take note of your units, be it in terms of cm, mm, meters, or whatever not. Okay. Find the amount of space in a box from A which is not occupied by the table tennis balls. Okay, so I think this is also pretty straightforward. Okay, you just how to find the space that is not occupied by the balls. So this is a question where it's a bit reverse. So just now we have seen in question 11 and question 19 where my composite figure calculation is I add up different parts together. In this case, I'm trying to find a space where I removed, okay, something from, this whole figure. So basically, what am I removing? I have a cube of 8 by 8 by 8. I remove 8 spheres with a radius of 4. Okay, so this is volume. So it's actually not a very difficult question. So volume of box, 8 cube. Okay, that will be just 512 cm cube. Next, we need to find the volume of these balls. Okay, 8 of them. So 8. Volume of a sphere is 4/3 pi r cube, where r in this case, since diameter is 4, radius will be 4 divided by 2, which is 2 cube. Okay, you will see that the total volume of the ball is about 256 over 3 pi cm cube. Then all you need to do, find the difference. You take 512 minus this. Okay, just now you also notice for some questions, okay, in between they did not evaluate this. Is because, okay, if you evaluate, you do some rounding off. When you bring a rounded off value over here, your calculation may lose some accuracy. Okay, but for your final answer, always do remember to apply accordingly the significant figures and the rounding off. So in this case, the volume, okay, of the box that's not occupied by the balls is 244 cm cube. Okay, correct to 3SF. Okay, otherwise with that will be the 5 questions for the homework of spheres. Okay, yeah. Okay, thank you. Bye bye.